Okay, we have which of the following is always true for a endothermic reaction, an endothermic reaction. All right, there's a lot of different things I could ask on this, so let's see if we can figure out what all we do know. All right, so being that it's an endothermic reaction, I know that delta H of the system must be a positive value because that's the definition of an endothermic system. Alright, that also means that the Q of the system is also positive because those must be doing the exact same thing because delta H is just essentially the heat. Alright, now I also know that the delta S of the universe in this case must be actually positive because it's actually told that it's a spontaneous process. Or it's implied it is, because why else would it be considered an endothermic reaction? Alright, now once we have those two things down, or those three things technically, we can start figuring out all the rest. Like for instance, delta S of the system, we're going to come back to that because we don't necessarily know yet, but we do know the delta S of the surroundings. And that's simply because that's always equal to the negative of the delta H of the system over the temperature. So since it was positive here, delta S of the surroundings must be negative. Alright, now technically that tells us what delta S of the system is. It's not that they're opposite signs, it's that we know from this line right here that the delta S of the universe is positive. Therefore, the only way I could get delta S of the universe to be positive is if I add a very large positive value or a larger positive value to the delta S of the system. And that's simply because delta S of the universe is equal to delta S of the system plus delta S of the surroundings. Only way to get that positive that way. Alright, we also technically know delta G of the system. This is another one implied that it's spontaneous, so delta G of the system must be negative.